class. Welcome to today's class, and I'm going to take you through MMA 414, that is Fourier series. And today we are going to look at the Fourier coefficients. And the first thing is to recall the formula. Recall that f of x equals to a0 divided by 2 plus summation as n runs from 1 to infinity of an cos n pi x over l plus bn sin n pi x over l. So, and the coefficients that I'm talking about, the Fourier coefficients are, a0, an, and bn. So we are going to look on how we are going to derive them one by one, and we are going to begin with an. So step one is to multiply equation 1 by cos n pi x over l, and our equation 1 is what I've recalled here, the initial equation. So multiplying it by cos n pi x over l, then integrate from negative L to L. So this is what you obtain. If I multiply that, you obtain this. So it will be integral from negative L to L of f of x cos n pi x over L dx equals to what? a0 over 2 integral from negative L to L over cos n pi x over L dx, and then plus the summation as n runs from 1 to infinity of the integral of from negative L to L of cos n pi x over L times cos n pi x over L dx plus bn integral from negative L to L cos n pi, not cos but sin n pi x over L times cos n pi x over L dx. And then we look for, in this case, we now look at the properties of even and odd functions. Cos is an even function. Cos is an even function. And cos is an even function. So when you multiply even times even function, you still get an even function. So nothing happens there. If you multiply an odd and even function, you get an odd function. And if you recall very well, integration in closed limits from negative L to L of an odd function, the integration is always equals to 0. So the whole of this will run down to 0. And we are going to remain with, and this is what we are going to remain with. This is what we are going to remain with. We are going to remain with integral from negative L to L of f of x cos n pi x over L dx equals to a naught over 2 integral from negative L to L of cos n pi x over L dx, and then plus summation as n runs from 1 to infinity of a n integral from negative L to L over cos of n pi x squared over L dx. So if you multiply even times even, that is cos n pi x over L times cos of n pi x over L, you get cos n pi x squared. So we proceed. If you come and integrate this one, cos n pi x over L, it will be a naught over 2. If you integrate, it will be L over n pi sine of n pi x over L, and the limits are from negative L to L. So this one is equals to a naught over 2 and then times L over n pi, and then you key in the limits. If you key in L here at x, the L of x will cancel with the L that is in the denominator, so you remain with sine n pi, minus, if you key in negative L in x, the L cancels with the L, so that you remain with a negative sine of negative n pi. And as you know, sine of anything, that is sine of n pi, is always 0. So everything else here will run down to 0. So this one disappears. And this is what we have. This is what we have from negative L to L, f of x cos n pi x over L dx equals to the summation as n equals to 1 to infinity of a n integral from negative L to L of cos n pi n squared pi over L dx. So we can drop the summation because it's just one component that we are adding. So the summation sign can be dropped, which implies that integral from negative L to L of f of x cos n pi x over L dx equals to what? A n integral from negative L to L of cos squared of n pi x over L dx. So the reason as to why I've dropped the summation sign is that I just have got one component here to add. So there is no need of me having the summation sign in that case. There is no need of me having the summation sign in that case. So we still proceed with the derivation. So if you look at this one is a calculus identity. So you have to recall something like this. Recall that cos squared of x equals to a half into x. A half into x plus, no, not x but 1. A half into 1 plus cos 2x. So we can substitute the same here. In our case, it implies that our cos squared n pi x over L will be equal to what? A half into 1 plus, you see, we are taking the coefficient, and then we are multiplying it twice. So it will be twice the coefficient n pi, twice the coefficient n pi all over L over x. So this is what we are going to integrate, and it will be an easier integration of the same. So we proceed on the integration, which implies that an integral from negative L to L over a half into 1 plus cos of 2n pi x over L dx. So we integrate component wise, which implies that an, we are going to integrate, let the half come out, integrate from negative L to L of x, not x but 1 dx, plus the integral from negative L to L over cos 2n pi x over L with respect to x. So the integration will be, if you integrate 1, you'll get x. So which implies that an over 2 into x, and the limits are from negative L to L, plus, if you integrate this, you are going to get, it is always 1 out of the coefficient of that cos. So in this case, we just take the reciprocal. It will be L over 2n pi of sine of 2n pi x over L, and the limits are from negative L to L. So in this case, if you substitute, you are going to get an over 2, so it will be what? L minus the negative that is here, you are going to get a positive, and then plus L of 2n pi. If you substitute L here, L is going to cancel with the L in the denominator, so that you get sine of n pi twice n pi. And this one, you are going, and then you subtract, you substitute the negative one, you are going to get, so the L will cancel with the L in the denominator, and you are going to get sine of twice n pi. And like I said, sine of n pi is always going to be 0. So everything else here drops down to 0, so that you remain with so it is the integral from negative L to L of f of x times cos n pi x over L equals to an over 2 of L plus L from this part, because the rest of this item has dropped down to 0. So this one is equals to, this implies that the integral from negative L to L of f of x cos of n pi x over L equals to what? It is twice, L plus L is 2. So 2 here, 2L will cancel with 2, so that you remain with an L. So we want to find the coefficient an. So what do? We divide both sides by L. So it will be an is equals to 1 over L integral from negative L to L of f of x cos n pi x over L dx as required. Thank you for listening. Come to the end of the derivation.